Hello all, welcome back to the third lesson of BLYNK IoT video series about virtual pins. Virtual pin is a BLYNK concept to exchange data between device and app. Physically it doesn't exist, but it acts as a channel between device and app, and total 256 pins are available, V0 to V255. It can be used to push or pull data. There are two types, push and pull. Pull is to get data from app to device, and push means device to app. And two methods of push are available, that is push request by app and device initiated using timer. So all the three examples we'll see in detail about virtual pins, which is very powerful, and once you understand virtual pins, it is easy to build a project. Now open new project and provide a name virtual demo, and select the hardware as NodeMCU. Connection type is Wi-Fi, and then touch on create. You will get an authorized token to your mail, registered mail, and touch on widget plus icon and add a slider. This slider will send analog data as a virtual pin. Touch on slider and touch on pin to select virtual pin. Select virtual and then pin as V1. Any virtual pin you can select. Now we are selecting virtual V1, and data will be from 0 to 1023 as it is analog data. Number of decimal places is nil, and then touch on back. Again touch the widget box to add a button. This will use to send digital data, for digital data through virtual pin. And button parameters, you select pin as virtual and select the virtual pin V2. V1 is already used, we will select the V2 for button, and mode as switch, so that either 0 or 1 is transmitted. This is for digital data button. Now we will see the code section. Before that, connect the NodeMCU to your PC and go to code generator. Select device as NodeMCU, connection as ESP8266 Wi-Fi, and copy the authorized token you received in your mail to this authorized token box. Use Ctrl V to paste, and then under example select get data. There is a example for get data. You select that example and wait for the code to get generated, and after it gets generated, click on copy to copy the code. Open the Arduino IDE, delete the existing void setup loop, and then paste the new code, and we'll delete all the unwanted comments to make it clear so that you can understand the code easily. You provide the SSID under the char variable SSID, char array variable, and char variable for password. Provide the password for the SSID, and we use BLYNK write function, BLYNK_write function, to operate on channel V1. Notice the usage of capital letters of BLYNK write. Capital letters means it is called from app. Now let us check up the code. Two header files are included, and then authorization code is given, SSID name and password, and all capital letter function, that is BLYNK write V1. V1 is assigned to slider, and we use the param.asInteger function to assign the value of V1 to the variable pin value, that is also an integer. So param.asInteger is used to read the value from V1 and assign it to pin value here. Now save this code, and then from under tools select the board as NodeMCU, and then under port select the port assigned to the NodeMCU. Now click on upload. Now the code is being uploaded. Once the code is uploaded, open the serial monitor. Now we will check the mobile apps side. You touch the play button and then touch the film button to see the virtual demo is online. Now use the slider. Now the value is sent through V1 channel and it reaches the serial monitor of Arduino at the other side. So from app, the V1 channel is used to transfer data and it reaches the Arduino serial monitor. So this is how virtual pin is used to send analog data. Now let us see how digital data is sent. For that you just copy the BLYNK_write that function again and paste it and change the virtual pin to V2. Yes, we have assigned a button widget to V2 virtual pin. We'll change the BLYNK_write code to V2. You can write any number of BLYNK_write function in this code. This is for digital pin and the code is same. param.as integer, asint is used to get the button status and it is assigned to the pin value variable as integer. That is, every time the widget changes state, a callback is done to get the value as integer data. So this is how virtual pin works on digital data. Now save this file and then click on upload and click on serial monitor. Now from the app side, mobile app, let us test. So on touching on the button, this through V2 the status is sent and the slider is also working on virtual pin V1. So both analog and digital data you get it on the serial monitor at the other end. Next we will see how to send string data and float data. For this, for sending string, we will add a widget, terminal widget. Touch on the plus symbol to open the widget box and select a terminal. So from this terminal we can feed in some string so that it will be received at the Arduino serial monitor. Touch on this terminal widget to do the settings. Touch on pin and select the virtual pin as V3. Already V1 and V2 are used. Now we are using V3. And then for add new line, you make it as S. So that new line is added for every line. Again touch on plus to add a float to add a step widget. This step H widget is used to send float data. Touch on that step H widget to do the settings. Touch on the pin and select it as virtual V4. Already we have used V1, V2, V3. Now assign it to V4. And step you select and make it as 0.5. So the slider will make steps in 0.5. We'll make it as send step yes and then touch the back button. So V1, V2, V3 and V4. V1 analog data, V2 digital, V3 is terminal and V4 is for float. Now let us check the code. Inside the code we will add a BLYNK_write function for V3, that is terminal. BLYNK_write is in caps, that means it is from call from app. So under this V3 function we use param.as str. Notice the usage of capital S, str for string, and straight away we use the serial.println. So param.as string is straight away printed on the Arduino serial monitor. From terminal of app, the data is passed through V3 channel, V3 virtual pin, and printed on the Arduino serial monitor. So param.asString is used for this under BLYNK write. And for return message, we'll use the BLYNK.virtualWrite to v3. It has got two parameters, that is the v3 is the virtual pin, and the second parameter is the actual message to send back. So as soon as you get the param.asString from terminal, you send back this message through the same virtual pin v3. For this we use BLYNK.virtualWrite. Now save this code and then click on upload and then open the serial monitor. Now go to the app section. So the first slider will send the value through v1, second button through v2, third is the terminal, that is the v3. From terminal type in some message and touch on send. So the data will be sent through v3 virtual pin and arrives at the terminal or serial terminal of Arduino, and again from there message will be automatically sent back according to the code. Now let us add code for virtual pin 4 v4, where we have added for testing float we have added one step H widget. So BLYNK_write v4, and inside this code we use param.asFloat. Straight away we use the serial.println param.asFloat. Now upload this code and then open the serial monitor. Go to the phone app and then touch the play button. So slider will send the analog value, button will send the digital value, and terminal will work as per that we have seen for virtual pin v3. Sending string from there will be received at Arduino serial terminal, and again a message will be sent back. And this step, if you touch on step, it is increasing in 0.5 values, but we are not receiving at the Arduino serial terminal. Let us check the settings for step. So send step, we will make it as no, then only it will be added to the previous value, otherwise only 0.5 will be sent. Now it will operate. Now touch on right arrow, it will add 0.5 to the previous value, and left arrow will detect 0.5. This is the float value. We have tested analog, digital, string and then float using virtual pins, which is pull data type. Next we will see push data, which is on request from app, mobile app, that is push data. The two types are there. First we'll check the request from app. First send all the previous widgets to trash, and then select a labeled value. Select a widget labeled value, touch on that widget to do the settings. Provide a title as uptime, as we'll be using millis function to display the uptime since when Arduino is running in milliseconds. We'll be using the millis function in the code. So give the name as uptime, touch on pin and select virtual and select pin as v5. You can select any pin as everything is free now. Select v5 for widget labeled value. And this is for centering the display. Provide some space and then select the font size as big. Now touch on the play button. You will not get any uptime value as code we are not uploaded. Now to generate the code, go to the code generator link, provide a NodeMCU device, connection as Wi-Fi and authorization token, paste it, and then select example as push data on request. Push data on request. Wait for the code to get generated and then copy the code. Open Arduino IDE and then paste the code. Now let us delete the unwanted comments so that we can easily understand the code. you need to provide the SSID, your internet SSID, and then the password for the internet facility. And we use BLYNK_read function. BLYNK_read in capital, that means from app. BLYNK_read, and the parameter in the sample code they have used variable pin underscore uptime. We will straight away use the virtual pin number V5 as parameter. So BLYNK_read V5, and inside that function we will be using blink.virtualWrite, and it has got two parameters. One is the V5, which is the virtual pin, and the second is the millis function of Arduino, which returns the uptime since when the Arduino is running, and gives in milliseconds. So in void setup and void loop, no other changes. Now save this file and then click on upload. Now let us check the mobile app side. Here if you touch the play button, you have to get the uptime in milliseconds, but we are not getting any uptime display. Let us check what is the defect. Let us check the labeled value settings. Under labeled value settings, the reading rate is under set push, so the request is from app, so you have to set this as 1 second or any other timing. That is, the refresh rate should be a request from app. You have to the reading rate should be generated from the app, so set this as 1 second. Now touch on play button, you will get the uptime since when the Arduino is running. It is 457 seconds. So this is very important, as the request is generated from app. The refresh rate should be requested from the app, and it is set as 1 second. Now let us check the digital data, how to send digital data using this request from push data method. To D1, a switch is connected. The D1 is GPIO 5. So in code always you have to mention 5 and not as D1. And the other pin of switch is connected to ground. So when you press the switch, ground will be applied. So we'll be using a widget value display. Select the widget value display. Provide a title as V5. So we will change it as D1, as we are setting value of D1. We will change it to D1 and select the pin as virtual and select V5. Title we will change it to D1. Input is V5, virtual pin V5, and reading rate, it should be set as 1 second, which is the refresh rate, and it is request from app. This is very important in this method, that is the push data method on request from app. Now touch the play button. Before that we have to do some changes in the code. Go to the blink.virtualWrite, that is a blink_read. Under this function you change it to blink.virtualWrite, and then two parameters. One is the V5, and the second parameter directly you can give digital read 5. That is, we are reading the GPIO 5 status using digital read. So always the D1 pin is GPIO 5. So you should use 5 and not D1 inside the code for NodeMCU. Since we have used the digital read method, you have to declare that pin as input using pin mode. So under that void setup, you have to use the pin mode to set that pin 5, that is GPIO pin 5 as input. So use pin mode and two parameters. First is the pin GPIO pin, which is 5, and the second parameter is input. Now we will use input underscore pull up, so that in code pull-up is used, so you need not use a pull-up resistor externally. So that pin will be initially high. So when the switch is pressed, it will go to low. So touch on play button. Now it is initially high, D1. Press the switch, it will become 0, that is low. So as we have used input pull-up, it is high initially. When you press the switch, it becomes low. So this is how to send digital data using push data method on request from app. Next is the push data method, which is device initiated. So we'll be using BLYNK timer function in this code. So the code to be selected is push data. Generate the code, copy that code, and then paste it inside the Arduino IDE. Now let us delete the unwanted comments and then provide the SSID name and password to that SSID. Then we create an object, timer object, from BLYNK timer class. So this is very important, as we have to initiate the request from the device. This is the initiate timer object now, and next is the my timer event function that we have to create ourselves, and from within void setup we use the set interval function of the timer object we created, that is timer dot set interval, and it takes two parameters. One is the timing, which we are given 1000L, that means 1 second, and second one is the call for the function we created, that is the my timer event. So every 1 second it will call the my timer event. And under void setup, void loop, we use blink.run and then timer.run. This is very important, as we are using timer. Under loop we have to use that timer.run. And let us see the user divide function that we created, that is my timer event. Inside this we use the blink virtual write, and it takes two parameters. First is the V5, which is the virtual pin, and second one we directly use the digital read function on the pin 5, which is GPIO 5. So first parameter is virtual pin V5, and the second one is the digital read pin 5. So we read the status of digital read at pin 5 and pass it on through the virtual pin V5. So as we are using digital read, we have to use in the void setup pin mode function, that pin as input. Let us use input underscore pull up, so that we need not use external resistor. Now save this code and then click on upload. It is showing some fault, so we'll correct it and then upload it. In the hardware side, we have a push switch, so that when you press the switch, ground is applied to D1 pin. Now let us change the settings of the labeled value on mobile app. Touch on that label value and change the name to push data. Select input pin as virtual V5, as we have used that V5 in code, and reading rate should be, that is refresh rate should be push. As it is device initiated, we use the timer event inside the code, it should be push. Now touch on play and press the switch, you can see 0, and release it, you will get 1. So digital data is pushed. It is device request. Thank you for watching.